Hey, all you cool cats and kittens. Today we're going to talk about piecewise functions. What is a piecewise function? Well, it's a function defined of two or more equations. So it's really a function made up of pieces of different equations. So we're going to have multiple pieces that we're going to be graphing and trying to solve and look at that way. And the big thing with these is how do we know when we're using which equation? Well, each of these, it's going to list exactly what our domain is or what values for x we're going to use. All right, so maybe we'll have one equation that we're going to use for a certain domain of x's and another one we're going to use for different values of x. So let's look at an example that's already written and graphed out. All right, so here I have three different pieces to my graph, right? That's pretty obvious, right? I got my second part of my graph and third part. So I have three different pieces in my piecewise function, okay? Now, where do these come from? All right, and that's where I have this equation written here. So this whole thing, all right, everything in that red box is what we would consider a piecewise function, all right? So I have 1, 2, 3 different equations that I'm going to be working with within this piecewise function, all right? Now, all of this stuff at the end, okay, where we have these greater thans or less thans and everything in terms of x, this right here tells us what's going on with the domain, all right? So we're going to start here. And if I look at my very first line, all right, this is when x is less than or equal to -2. So if I look at, here's x is less than -2, I'm just going to draw a little dotted line here, all right? So now this tells me that for any values for x that I would plug in, so anything less than -2, like -3 or -4 or -8, if I wanted to plug those numbers in, I'm going to use the equation that's matched with that, which in this case is -x minus 7. So if I wanted to make an xy chart, and if I wanted to plug in -3, all right, -3 falls under this domain category, which means I use the equation listed for that. All right, so this would be -x. So if I plug in -3, -3 would be +3 minus 7 would be -4. And sure enough, if I go to my graph at -3, go down, -4 is where I have a point. Okay, now that continues for all of these then, right? Looking at my next one here, if I choose x is between -2 and +2, I use this equation x squared. All right, so if I wanted to plug in 0, 0 is definitely in this range, right? It's between -2 and 2. If I plug 0 into x squared, 0 squared is 0. Sure enough, 0, 0 is a point on my graph. All right, and the last one we have here is when x is bigger than 2, okay? And again, if I go up here, right, here's x is 2, everything goes this way, right? I'm going to be using this equation here, and it's just 6. So anything I plug in, like 4 is bigger than 2, right? If I plug 4 in, well, I always get out 6. And sure enough, at 4, I'm at 6. So that's kind of what the piecewise function does for us, right? Each of these pieces in the domain, right, and that's the first thing we do is look at the domain and then figure out what equation are we going to use. All right, so let's look at another example here. Again, I have 1, 2, 3 pieces for my graph. So this is 3 pieces for my piecewise function. All right. Then, okay, if I wanted to graph this, right, I would look at each piece in my domain. All right. So for everything smaller than -2, all right, I would use my first function here. All right, so that would be stuff in red, right? So if I look at my XY chart, right, and I want to plug in different values, and that's how we're going to do this is graphing on paper, you're going to plug in values. I'm going to choose values less than -2, so maybe -3, -4, okay, those are all less than -2, all right? And since they're in this domain range, that tells me I use this function, right? So if I plug -3 into that function, I'd get 0. If I plug -4 into that function, I'd get -1. So there I got a couple ordered pairs already. Okay? And we're going to do that for each of our pieces of our function. I'm going to plug in 2 points. So if I find some couple things between -2 and 3, well, maybe I even just plug in -2 and 3, right? And it's a good idea to start at these ending points here. All right, so if I plug in -2, add the value of -2 is 2, with the negative in front would be -2 plus 5 gives me 3, all right, and so on and so forth, okay? And then again, I do the same thing for my last one. This is where values are greater than or equal to 3. Maybe I choose something like 3 and 5. and again, I'd plug those into my function. Okay? All right. So now what if we are given a graph and we want to come up with the equations that represent this? All right. So we know we're going to have our piecewise function. Okay. And now I have two pieces, so I know I'm going to have two equations here. All right. So let's maybe start with the one on the left. This one over here, and you can see I got an open circle here. All right. So right now, I know that this one breaks at 0. Right? And the only part of my graph happens when my x's are less than 0. So that's my domain for this one. All right? And then I'd have to come up with my equation, right? Well, I know my y-intercept for this is going to be at 1, 2, 3, 4, right? That's where it crosses here. And it looks like I have a slope of down 1 over 2. Down 1 over 2. So I'd have a slope of negative 1/2, right? So negative 1/2 x plus 4 would be my equation for this one. Now, if I look at this one here, all right, I got a solid point here, all right, which means that value is included. And again, my graph is starting at 2 and it's going this way, so my domain would be everything greater than or equal to 2. Those are the x's that are included. And now if I want to come up with my equation, well, it looks like I have a slope of 1, so it would just be x plus, and then now I got to figure out what my y-intercept is. I could use my equation and try and do that, or I could just go down 1 over 1, down 1 over 1. All right, I think that's quicker here because it's an easy graph. It gives me a y-intercept of 2. All right, so let's look at another example here. All right, I got an open circle here. I got a closed circle here. Why don't you pause your video and see if you can come up with this one on your own. All right, so I came up with minus x minus 4 when x is less than 0. And I have just x when x is greater than or equal to 0. So my first one here, I got a slope of down 1 over 1, right? So that would be a slope of negative 1, which is where the negative comes from in my x. And then, of course, my y-intercept here is negative 4. All right. The other one here, I have a slope of up 1 over 1, which would be positive 1, or positive 1x, or just x. And then I have a y-intercept of 0, so I wouldn't have to have the 0 at the end. All right. So let's try this the next way then. Let's look at and see how can we graph these on paper. All right. So if I have my coordinate grid here, all right, then what I'm going to do is I need to look at my domain. Always start with your domain. Okay, and right now I'm using my first function when everything's less than or equal to 2, and my other ones when things are bigger than 2. So I'm going to find where 2 is in my x-axis, and I'm going to make myself a little dotted line. Now this isn't part of your graph, but I think it's a great reminder for you that when you make your graphs, you are never going to cross that line. All right, that's where your domain breaks. That's where you switch from one function to the next. So if I start with my first function here, all right, negative 2x minus 1, this is when things are less than or equal to 2. So I'm going to plug in 2, and I'm going to plug in something less than 2. Well, 0 is an easy number, so I'm going to do that. All right, but again, you can choose whatever you want. So if I plug in 2, this would be negative 4 minus 1, or negative 5. If I plug in 0, my x's cancel, I just get minus 1. All right, so at 2, I'm at negative 5. 1, 2, 3, 4, 5. So my point ends up right here. All right, and then at 0, I'm at negative 1. All right, so now I can draw my line, but again, I don't cross my dotted line. Right, so my function's going to keep going like so. Now I'm going to look at the second part of my function, negative x plus 4, and this is when x is greater than 2 is when I use that function. So I'm going to plug in things greater than 2. Now this is the part that sometimes gets a little tricky. I want to still plug in 2, and I'll choose something else. All right. Now, yes, 2 is not included. It's just greater than. It's not equal to. But that's where we do the open circle thing like we did with inequalities. All right. I still need to know where this stops or starts. So if I plug in 2, this would be negative 2 plus 4 is 2. If I plug in 5, negative 5 plus 4 would be negative 1. All right. So my first point was at 2, 2. I know I have an open circle because that's not included. My next one was at 5 and negative 1. So my graph would look like so. All right, this one here, I'm going to go ahead and pause the video and let you try this one on your own. All right, so I identified my break and my domain is at 3, so I drew my dotted line here at 3. All right, and then for my red line, I used the first equation there, the first part of my piecewise function. I plugged in values that are less than or equal to 3, so 3 and 0, plotted those points. For my second equation, I did the same.